Alright, in this video we're going to introduce graphs of polar equations. So let's graph each of the following and comment on the graph. So we're going to start with r equals 4. Now we've seen similar ones to this in our section on polar coordinates, but r equals 4, as long as the point is 4 units away from the origin or 4 units away from the pole, it will be part of this set of points for r equals 4. So as we can see, all those points form a circle where the center is the pole or the origin and the radius is 4. Again, each of these solid rings represents a unit of 1. So r equals 4 is a circle where the center is at the origin and the radius is 4. We also saw that r equals negative 4 would also produce this same graph. For r equals negative 3 square root of 2, it's slightly larger than 4, but each of these points are 3 times the square root of 2 units away from the pole. So r equals negative 3 square root of 2 is a circle, yet again, where the center of the circle is at the pole or the origin and the radius is 3 times the square root of 2. So about 4.2 or so in that regard. Part C, we have theta equals 5 pi over 4. In the last section, we saw how to convert this to rectangular form, but here is 5 pi over 4, which is, it's going to be a line, so it extends infinitely in two directions. And in terms of this graph, it's a line where the y-intercept would be the origin, or it does go through the pole of the polar coordinate plane, and it makes an angle of 5 pi over 4 with the positive x-axis, or the polar axis. So it is a line that, in this case, the slope would be the tangent of 5 pi over 4, which is 1. For theta equals negative 3 pi over 2, here we have negative 3 pi over 2 is equivalent to pi over 2 in terms of coterminal angles. So going up to pi over 2, we just get a vertical line here. So this would be the equivalent of the line x equals 0, or the y-axis. So with these examples here from 1a through 1d, hopefully you notice the pattern that when it's r equals a number, it's a circle with the center at the origin or at the pole, and the radius is equal to that number. It actually should be the radius is equal to the absolute value of that number, because as we saw with negative 3 square root of 2, the radius is 3 square root of 2. So our radius is equal to the absolute value of that number. For theta, it's a number, theta equals a number. It's a line through the origin where the slope of the line is the tangent of that number. So again, r equals a number is a circle centered at the pole or the origin with a radius equal to the absolute value of that number. And if it's theta equals a number, it's a line through the origin or through the pole where the slope of the line is the tangent of that number. All right, that about does it for this video. Thanks for watching, and I'll see you next time.